what are we going to do today? We're going to address the question today of why do we need alligators in the swamp? And sometimes it doesn't sound like a very important question, but if you live in Florida, where there are lots of alligators, or you could change this question and say, why do we need lions? Why do we need elephants? Why do we need killer whales? Why do we need any animal that's dangerous? Why do we need bees or mosquitoes? And the question is we have to start to understand why all these animals are actually in the environment and why they're important. Not only why they're important to the environment, but maybe why they're also important to us. Eggs, they're on high ground. And guess what? The ants come and lay their eggs there too. And they harvest the fungus because of the rotting material that's in the nest. So in fact, this nest creates a whole community. It's a whole different environment.
You know, earlier when you were showing us that the turtles, the ants, and the alligators were putting their eggs in the same nest. Mm-hmm. Well, since the nest was in that little area of water, how would the ants get to the nest without drowning?
Great question. Do you know the answer? Do you have a guess? Well, here, let's be scientists for just a minute. How would you, if you wanted to get to the middle of a pond, okay, how would you get to the middle of the pond? So how would you get to the pond, right? First thing is, right, you'd swim. So one thing is you could swim. Do ants swim? I don't think so, okay? So how else would you get to the middle of a pond? Hang on.
Well, you could probably climb up a weed that's leaning over or jump on a leaf and then... Bingo. So you're a scientist, absolutely. So what you have is a hypothesis, right? So you say you could wrap.
Okay, so today I'm talking about what the smallest thing is that a person can see. And like most questions, when you start asking a question like this, then it brings more questions into your mind. And what I want to do is I'm trying to connect this talk up to some of the research that I do. And the research that I am going to talk to you about is a field called DNA origami. And I'm going to just zoom in, and you can see here that we see some that are facing up and some that are facing down. And this is this for me, once we figured this out, that we're seeing both face up and face down, now we have a new scientific problem. Can we figure out how to make them sit on the surface so that they're only facing face up? Right now, we're still working on that problem. We haven't figured it out. Maybe you guys will have ideas.
Well, as you said, you wanted to control which direction the origami is facing. Couldn't you add electromagnetic particles to the origami and then put it on an electromagnetic plate and then reverse the polarity or such to
make them flip around?
Yep.
There's a technology called e-paper that uses that exact method to flip little nanoparticles so that there's a white side up or a blue side up, and you can flip them upside down. We think that origami are too small to do that, but we're really interested in using electric fields to make them flip. So that's a really good question. Yeah.
Well, thanks a lot, everybody. Thanks for coming out here. So I'm here to spend a few minutes today trying to answer this question. Why can't humans walk on water and climb on walls with their fingertips like spiders? So to try to answer this question, I think first I got to ask you all some questions. First, how many of you like to be creative and use your imagination? Well, that's a lot of you. That's a lot. Okay. How many of you might like math or science? Anybody? All right, that's pretty good too. So what we're trying to do, a lot of this work in nanomedicine is actually to try to detect the diseases way early on, or try to actually cure the diseases so that we don't have to, when you guys are up here and you're asking some people your age and they say, hey, what is cancer? No one will raise their hand. Everyone will have forgotten what cancer is because we've cured it. So that's kind of the whole goal.
If these devices are so small, why can't you inject it into a person's bloodstream and get it to separate and trap the cancer cells?
Haha, actually, you got, you should join our team because we actually have a proposal that we have funded to do exactly that. What we would do is, let's say if somebody had cancer, a lot of times what they do is they cut it out. And then what we would do is we would implant a very small, we call it an implantable micro-oncologist. And we'd put it in place there, and it would just sort of all the time be looking for cancer cells to see if cancer is coming back. So there are steps to do that. I guess one of the hardest challenges is one is your body doesn't like things in it. So your body's good at rejecting stuff. So you got to kind of overcome that. And also, again, connecting to the microfluidic device is sometimes difficult. So, but that's a good vision of where we want to go.